Okay, good morning, everybody. Now the recording is on. So today we are talking about a concept called virtual private cloud, VPC in short. So both from the exam perspective and the real world scenarios perspective, VPC is undoubtedly the most important topic. The most important topic. So it's a tough topic also for all the people who have come from a development background. If there are any people who have come from a networking background, these concepts are pretty straightforward. It's kind of a first language for them, but not for us who have come from a development background. I'll try my best here, but you may have to do some of the fundamental stuff. You may want to go read online also. The most fundamental stuff. I'll try my best to explain, but given the time, I may not cover the most basics. But let me start with something here, okay? So you know that every single computer that's connected to internet is, they're all connected. They're all connected, and every computer is uniquely identified with something called IP address, right? So there are two versions of IP address, IP protocol, IPv4 version 4 and version 6. In version 4, your IP address is a number dot number 1 through 255. So your IP address could be 69.54.128 times 128.176, something like that.
Are you sharing anything?
Oh, I'm sharing. Yeah, I mean this screen here. Are you able to see?
No.
I can see it.
Okay.
I can see it as well.
Yeah,
Okay.
yeah, I can see it.
Okay. So
Log out and log out.
yep. So this IP address, every computer is uniquely identified with their IP address, and there are IPv4. And IPv4, you have a number from 255.250, until 255. Dot another number until 255 and another number until 255. So there are some finite number of IP addresses. I know it's a few billion IP addresses with that combination, and it's not enough in this IoT, Internet of Things world. You have your fridge has an IP address, and your Nest thermostat has an IP address, and everybody wants to communicate with everything. And you have your smart cities case. Every traffic light has it's a smart traffic light, right? So they'll be able to come. They have an IP address. They want to be able to communicate, right? So a couple of decades back, it started this, version 6. Version 6 is, it gives several hundred times more than, not 100 actually, it's much more than that. So we will not have this IP depletion issue with IPv6, okay? So it's, with IPv6, you will not have that problem. And then pretty much every single Internet of Things device can have their own static IP address. And we are good for next 100 years probably. So that's IPv6. So anyways, the point is the IP addresses. So every computer has this unique name or unique number. That's the IP address. So that's how you identify it. So the point here is that the concept of virtual private cloud is the concept of virtual private cloud is Let's step back and talk about your own data center. Let's say you have your own data center in your organization right now. So your network team creates this whole, the virtualization, okay, the network virtualization. They will create different logical IP groups. They will say that, all the database servers, they will sit in this logical area. They say that, all the database servers will sit in this logical area. They will assign a logic, they belong to a logical group. All the web servers, they belong to another logical group here, they sit here. So they divide the entire network into multiple segments. They do that right now in your own organization. Okay. So, but what happens, it's a multi-tenant environment. When you go to cloud, it's a multi-tenant environment. You are sharing all the network resources with a million other people. So how can you do this in cloud? That's a challenge, right? So AWS has provided this concept called virtual private cloud. Essentially, you will get your own piece of cloud here. So it's a completely logically isolated section of cloud just for you. So other people, obviously you have that logical separation. Other people cannot enter into it. And it's not just that. It's like in your own data center, you can define your own IP range. There is something called IP range of IP addresses for your network, and you can logically separate them out. You can say that this range of IP addresses are for DB databases, this range of IP addresses are for web servers, this range of IP addresses are for application servers. Everything you can segregate it. You can do it like how you do it in your data center, like how your network architects do it, you can do that. So you will have with VPC, you will have a complete control over your networking components. There are some networking components which we'll be talking about. One is your own IP range. You can say that, hey, I'm creating this virtual data center. You are essentially creating a virtual data center for your own account. That's just for you within your own account. Okay. So, and when you create this virtual cloud, you can define your own IP range. Hey, there are a lot of private IP addresses. One of the popular one is 10.0.0, 10 dot something. Okay. So I will talk about that, but essentially you can define that. I want this logical cloud. This is isolated cloud section. Okay, I want this to be in this IP range. You can define your own IP range, like how you do it within your own data center. And then there is another concept here called subnet. It's a networking concept here. It's called subnet. Subnet is nothing but a logical group of IP addresses. It's a range of IP addresses. You are putting them together and say that, hey, this is its own, this is a logical IP. Okay, they will have their own rules. They will have their own, there's something called route tables. We'll talk about it. So they will have their, it's a logically separated one. If the one subnet wants to talk to another one, now you can define your rules there. And then there is another concept called route tables. I'll talk in depth about routes, route tables, etc. But I want you to understand one thing here. So in all of your homes, you have your routers, right? So your internet router. So if you go to the router will expose, you will have a single public IP address, but internally you may have different devices connected to that router. Let's say you have a Windows laptop, you have a Mac, you have an iPhone, you have Apple TV, and a couple of other devices. But when these guys go out to, let's say, google.com, all of it goes through your router only. Router is acting as an orchestrator, as a front gate, right? For all the network going out, for all the network coming in, your router is acting as a gate for that. So that guy will, when a packet goes out, your network packet goes out, it will go out as your public IP. So what I'm trying to say here is that, so let's open my command prompt and open this. I'm using this command called ipconfig to find out what my IP address is. This is my IPv4 address, 192.168.1.239. But this is not my public IP. This is my router is saying that this is my private IP, 192.168.1.239. Okay, but if I go here and then ask for what is my public IP, what is my IP, and I'll know this is my public IP. This is my public IP address, 69.14.25.122. But this is my private address. So I have my own LAN here, local area network, right? So that's about the subnets, okay? And so essentially with AWS, with virtual private cloud, you will be able to define your own virtual networking environment. And within that, you can logically group the IP addresses called subnets. You can define several subnets. And you can say that, hey, this subnet is going to be in this availability zone, and this subnet is going to be in this availability zone. So one most important point we need to understand here is that your subnet must be in a single availability zone. When you create a subnet, that must be in a single availability zone. Your subnet cannot span multiple availability zones, because we're saying subnet is a small group of IP addresses, right? And then we want all the logically grouped instances or resources in a single availability zone. We want them to be as closely as possible. So before we dive in, I want to talk about, go to this website called CIDR, CIDR.xyz. Okay, this is a classless interdomain range. Okay, this is your IP range. This is your IP range. So let's say I'm creating a new VPC. Okay, I'm creating a new virtual private cloud. What I'm doing is 10.0.0/16. You have to know what this /16 is, /8 is, etc. So this is your IP range. So by putting /16, what we are saying is, this is your IPv4, right? So you have your 8 bits here. These are called octets. 8 bits here, 8 bits here, 8 bits here, 8 bits here. Right? See this one here, essentially. So 10 is, these are the individual octets, right? See here, this is 2 plus 8. I hope you know what I'm talking about. 0 times 2 to the power of 0, 1 times 2 to the power of 1, 0 times 2 to the power of 2, 1 times 2 to the power of 3. It's a binary, right? So this is your, 2 plus 8, 10. This is 0. So by /16, what we are saying is, out of this complete 32 bits within an IP address, I'm going to use 16 bits just for the subnetting. Meaning that the remaining 16 only are available for my IP addresses, is what I'm saying. Okay, so if you do a /16, meaning you can only use 16, but this for 16 bits you can't use it. They'll be used for internal subnetting regions, and you can only use the 16 bits for your IP addresses. And the number of IP addresses, look at it. So first IP is going to be 10.0.0.1 all the way from here until the last IP is 10.0.255.254. You know how many IP addresses you will get? 65,536/16. This is your range of IP addresses. A lot of you don't know. I mean, I'm not an expert in networking also. I mean, this is not my bread and butter, but hey, it's we'll understand. So if I say that /8, let's say, if I say that /8, that means you're using 8 bits for your subnetting, but the remaining 24 bits you can safely use for your IP addresses. Okay, look at how many number of IP addresses you can create with /8 kind of if you want to create a /8 kind of network within your own company, you will get 16,777,216 IP addresses, all the way from here till here. Okay, and this is /16. I talked about /16. Let's say, see that /2. Then only 2 digits will be used for masking, and everything else will be used for your IPs, and you will get 1,073,000,000 these many IP addresses. Okay, so Amazon allows only up to /16. So you can't go less number than 16. Meaning, when you create a virtual private cloud for your own, you have to go with the CIDR range, your IP range only up to /16. Meaning, you can only create a virtual private cloud with about 65,000 IP addresses. So you can't go less than that. You can't go 12. If you go 12, then you will get 1 million IP addresses, but Amazon does not allow it, either 16 or above. Let's say 24. So if you use /24, so what we are saying is you can't use these 24 bits because these are used for net masking, subnet masking, and then you can only use these remaining 8 bits. You can only use these remaining 8 bits for the actual IP addresses, and you have 256. You know that. I mean, because there are only 8 bits, and with 8 bits, only 256 possible, right? So is it like for any of you? I mean, probably first time when I heard it, also it was Greek and Latin. Don't I want to say that. So anyone feels Greek and Latin? I wouldn't get surprised, if you feel so. So don't worry. We will go ahead and create a VPC and talk about it. But some of these concepts, I want you to go and read more about it, or watch more something online, more fundamentals. If you don't know what an IP address is, IPv4, IPv6, and CIDR, okay, subnet masking, etc. We'll talk about whatever is needed for this. Okay, so let's talk about it. So you get your own IP range. That's the beauty. So what we are going to do is we will create a new virtual private cloud. Oh, by the way, you may be wondering, hey, what happens all along? I've been creating a lot of EC2 instances and databases. What was happening? Well, for every AWS account, okay, a default VPC gets automatically created. So a new VPC was already created, the default VPC. So that's where you have been playing with it. A default VPC has already been created for you, and you have already been using this these concepts, okay? But you don't know that you've been using it because the default VPC. Now we will walk through it. When you create a new EC2 instance, now I will show it to you where the VPC section is. All along I've been saying that, okay, go next, no, don't worry about it. We'll talk about it later. Now is the time. So take a look at this one here, guys. So you have a region here and you have two availability zones. And when you create a VPC, that VPC is region specific, but it's not availability zone specific. Your VPC will span availability zone. Now, within this network, VPC is nothing but an isolated network, right? So you will get your own isolated network. And when you create this VPC, you have to give your own CIDR range or IP range. So what I'm going to do it is, I'm going to create a VPC with this CIDR range, 10.0.0.0/16. How many IP addresses do I get? About 65,000 IP addresses. Okay. So within that, when you create a new VPC, what happens is Amazon internally creates a router. It's an invisible router, but it creates a router for you and make it available. Also, there is something called a route table. So this is a router, right? This router is the one that's responsible to send the traffic out, to send the network packets out, or when somebody is trying to reach to an EC2 instance inside your VPC, router is responsible for, okay, where do you want to go? Okay, I have these many instances here. Where do you want to go? Okay, I want to go to this particular IP address. Okay, let me see what's the route here. If you want to go from place A to place B, how you use your route map, right? Similarly, this router uses this route. Those routes are defined in your route table. There is something called a route table there. Okay, your router will look at it. These concepts are there right now in your home network also. When someone is trying to enter into your network, it comes to the router, and then router will say that, okay, what IP address do you want to go to? Do you want to talk to my Apple TV or MacBook Pro or Windows laptop? Where do you want to go? Because they have their own IP addresses, and then it will route the traffic. But those should be defined in the route table. So when you create a new VPC, router will automatically be created. It's an invisible router will be created, and this router will look at something called route table. We will talk in depth about it. You will understand every single thing about route table. But here in this route table, all the routes are defined. Okay, so by default, when you create a VPC with this IP range or CIDR range, from here onwards, we'll call it CIDR range. Okay, 10.0.0.0/16. A default route table is created, and with this route, 10.0.0.0/16, target is local, meaning whoever has this route table attached, they will be able to talk to everyone within that VPC. By default, if I create an EC2 instance here, if I create an EC2 instance here, there is a route between these two, which is this one. There is a local route between these two. So there is a connectivity. You'll be able to exchange the packets across. And in addition to the default route table, there is something else called network access control list. A default network access control list will be created. What is it? You don't know yet. I will talk about it. A network access control list is exactly like your security group, but security group is at the instance level, right? This network access control list are the rules defined for your whole subnet. When you create a subnet, within this whole VPC section, you'll be creating subnets, right? So subnet is a range of IP addresses. So who can talk to the resources within that subnet? Who cannot talk to it? who should be allowed, who should be denied. All those rules can be defined in network access control list. We call it network ACL. Those are the rules. So when you create a VPC, my point is, when you create a VPC, an invisible router will be created. You will not be able to see it, but this router and the default route table will be created to give, and it gives route to all the people within the VPC by default. And a default network ACL will be created. A default one will be created, and all the default rule is allow all, meaning allow to everyone. Inbound traffic fully allow, outbound traffic fully allow, meaning no restrictions to your subnets, no protection. We will change that, no worries, but this is the default. By default it gets created. Yeah, I wanted to depict the same thing here. So now the point is, we will create a new subnet. Why are we creating this VPC? This VPC, we are getting a virtual network environment. It's like our own environment. It's like in an office, pretty much. It's within this, I can do anything. This is my own cloud with my own IP range. That is the beauty. No one is dictating it. Even though it's a multi-tenant environment, I'm not getting the feeling that it's multi-tenant. I'm getting the feeling that this whole thing is me. That's the beauty about it. So what we will do now is, within this 65,000 IPs, right? 10.0.0.0/16. Now we will create a subnet here. We will call it a public subnet. Why am I calling it in a public subnet? Is because I'll tell you my idea here. My idea is, I want to create two subnets, and my architecture is, I have some web servers and I have some application servers. These application servers are backend servers, or you can even put your database servers there. They are not exposed. My public web servers, they should be in WebDMZ, meaning they should be able to take the request from internet. But my private or my application servers or the backend servers, they should be in a separate subnet, and I don't want them to be publicly available. I don't want them to be in my demilitarized zone. My web servers should take the traffic from outside, but not the database servers, or not my application servers, or not my backend servers, any of the backend servers. Only these web servers should talk to them. That is my beauty here. So I'm going to create two subnets here. One I call public subnets, where I'm going to put all of my web servers, and I'm going to create another subnet called private subnet, and I'm going to keep all of my backend servers. And only my web servers can talk to my backend servers. That's the idea here. Now, I'm creating a public subnet here, right? When I create a public subnet, I can create my IP range. And look at this one here, guys, 10.0.0.0/16. This is my total VPC, my 65,000, about 65,000 IP addresses. Within that, my public subnet is taking 10.0.1.0/24. When I say /24, meaning I will use this 24 bits for subnetting, but I will use only the 8 bits for your IP addresses. So you'll get about 255 IP addresses. We just put it here, right? 10.0. If you want 1.0.0/24, how many addresses? 256. Out of this 256, Amazon keeps 5 IP addresses. So you can essentially use 251 IP addresses, meaning you can create within this public subnet, you can create up to 251 web servers, because you want this to be public, right? How can I make this public? We'll talk about it. But essentially, you will go create your EC2 instances, your web servers, and put them in this public subnet. How many can I put it? 255. How? Because it's a /24. This is the one. This is your public subnet. And I'm creating a second subnet called private subnet. Okay. And this private subnet, and understand here, I'm putting my public subnet in one availability zone and private subnet in another availability zone. Your subnet cannot cross the availability zones. One availability zone can have more subnets. One availability zone can have 10 subnets also, but subnet cannot cross the availability zone. Okay, so now I'm creating another subnet called private subnet. I'm putting this guy in a different availability zone. And now look at the IP range here, 10.0.2.0/24. This is 1.0, this is 2.0. Now, how many, another 255 resources can be provisioned within this private subnet? Meaning, if I want to create 255 database instances or 255, some application servers. Let's say this is Apache, these are Tomcat application servers. Then I can put them here. And these guys, I will protect them. I will make them private. I will protect them. They will not take the traffic from internet because I don't want them to. I don't want to expose it. And this is very natural, guys. Go talk to, because you guys are now solution architects, right? With this understanding, when you go talk to your network people, I highly encourage you go talk to your network people. Just have a casual conversation, lunch conversation or something, and then talk to them. They will. It's all natural. They do it. They do it day in, day out. This is what they do. But we know now. So now this router will send the traffic to both public and private subnet. There is a route. It doesn't send yet, but there is a route. What is this? See this one? Your routes are defined in the route table. This route table is read by your router. So now your route table is there, right? So now by default, when you create this subnet, okay, your default route table, the reason it is default route table is because when a new subnet is created, that route table is attached to this. What it means is this default route table is attached to this public subnet. What are the routes here, guys? Just only one route, which is 10.0.0.0/16, meaning there is a local route to all the people within this VPC. So all the resources here will have a route to all the resources here in the private subnet. If you don't put any restrictions, this guy will talk to this guy. And now also for each subnet, there are two things that are associated. One is the route table. Route table will say that all the resources within this house, who can they talk to? Meaning, what kind of routes do they have it? How would the packet transfer happens? Network packet, when packet goes out or packet comes in, what happens? So here, the only route here we have it is they can talk to the internal, everyone within the VPC is what it's saying. Now let's do this one here. There is another one that's attached to this one, that is a network access control list. A network access control list must be attached to a subnet also. And by default, there is a default NACL or default network ACL is already there, which all the rules says that allow everything, inbound, outbound, everything, allow it. That is what gets attached default. And same thing with private subnet. So at this point, even though I created two subnets, they both have exact same rules, meaning they will be able to talk to them. All the resources here will be able to talk to the resources here in the private subnet because there is a route here. And because the network ACL, there are no restrictions there. Everything is allowed at the network ACL level. So, makes sense, guys? So far, we will do this in and out. Trust me on that. Just hang in there. We will set this up. I will show you how to do this, and you will do several of them. You will walk out with so much confidence. But first time when you feel I came from development background, and definitely network is not first language for me, and it was Greek and Latin. Understand it. And every single one of them feels that way. So I want you to know that. But we will, and before you go to the exam, I'll make sure you are like masters in it, not just understanding it. So it's my promise. Don't worry. We'll do several of them. So at this point, right, let's recap what we did so far, what we wanted to do. Okay. And then we will jump into the lab. So we created a virtual private cloud here. Okay. Our own isolated network with this IP range 10.0.0.0/16. When you create a VPC, by default, it creates a route table that gives a route to all the resources within that VPC. And also it creates a default network ACL. Network ACL is a police guard for your subnet. Understand, network ACL is a police guard for your subnet. It applies all the rules. This guy actually sits here right in front of the public subnet, and then see when someone is trying to go into that, or when someone is trying to go out of it, it will look at it. Okay, do you have access? This is exactly like a security group. There are some differences. Exactly like security group, but security group is at the instance level, but this guy governs at the subnet level. If there are 251, in this case, right, if there are 251, there could be 251 web servers. Let's say there are 200 web servers here within this public subnet. Who can talk to them? Are these guys, who can they talk to out? Everything is governed by this single network ACL. That is at the subnet level. Security groups are at the instance level. And there are a couple more differences. We'll talk about that.
Venkat, have a question.
Absolutely.
So if there are multiple public subnets in availability zone 1, how does the route table and the ACL get linked to that other public subnet? And this is my first question. Other question is, let's say if there are 3 availability zones, in availability zone 2, I have another public subnet which is connecting to private subnet in availability zone 3. So how does this route table and the default ACL gets connected?
Okay. So let me dissect it. One subnet, to make things easier, right? To make things easier, I'll say this. One subnet can have only one route table attached, period. One subnet can have only network ACL, period. Does it change any of your questions? Subnet cannot have multiple route table association. One subnet can have one route table association.
Okay, so yeah, each public subnet.
Go ahead.
Sorry, go ahead. Yeah.
All the routing rules, these are called routes actually. So all the routes within the route table will be read by the router. Okay. And one route table can only be associated with a subnet. It doesn't matter public or private, but one subnet can have one route table only association. Similarly, one subnet can have one network ACL only.
Yeah, the thing I didn't understand was in the default route table, the destination, the CIDR range is the VPC CIDR range, right? So for other public subnets also, if we like you're saying, it has a separate route table, then it's the same destination, the CIDR range will be there for
Exactly.
that all.
That is
Oh,
the default one. That's a
okay.
default one. But hold your question for a couple more minutes. This is the default one. The default one meaning everyone, what it means is every resource within the subnet will have a route to every resource within this complete VPC. Meaning, imagine this VPC as a big house. Within this big house, everybody will have a route to everyone else. Everyone in the house in this VPC will have a route to everyone else. Whether they have a route out to internet or not, whether this guy will be able to talk out to the internet or not, we will see that. But every single person within the big VPC house will be able to have a route. I'm not saying they will be able to talk to each other, but there is a route if they want to talk to. Does it make sense?
Yes, Venkat. Yeah.
There is a understanding. There is a route to it. Everyone is interconnected within this VPC. Everyone will have a route. Okay, whether you want to allow it or not is defined here in your network ACL. Whether you have access to that particular subnet or not, defined there. So hang in there. I will show you with an example.
Yeah,
Okay.
and I don't know if you have already discussed about what are those columns in the destination route table. I mean, there is destination and target. How do we interpret them?
Yeah, I'll tell you. Just hang in there for one more.
Okay, sure.
Okay, yeah. I'll talk about that. So we have a public and private subnets, right? So what I'm doing now is, who should sit in public subnet? Your web servers. So let's go ahead and provision some couple of web servers in this public subnet. Okay. So, and let's go ahead and provision a couple more servers into this private subnet. These one I'm calling it as app servers. My intention is I will install HTTPD or Apache here, but I want to install Tomcat here, and my Apache will talk to the Tomcat. But my Apache should be in DMZ, meaning my Apache should take the traffic from internet, but my app server should not be exposed. Is the goal I'm working towards. Understand? You can achieve the same thing without creating a brand new custom VPC, guys. That's what you're able to do it. You can mess with the existing VPC also, but I want to define my own IP ranges, and I want to define my own private IP range. Okay, and I want to create my own subnets exactly like how I do it in my office. Okay. So now let's look at for a second here. Let me go back here. Okay, let's provision these EC2 instances, and we have one public subnet, one private subnet, and all. Beautiful so far. Now, the point is, let me talk about this public and private subnet. Let's define those. When I say public subnet, they will take the request from internet. Public subnet meaning they are web servers, meaning they are in web DMZ, demilitarized zone. They will be sitting in a network area where they are potentially prone to attacks from internet, because their job is to take the request from internet, because they are web servers there. That is what I mean by public. Not I mean in general, right? When we say public, that's what it means. Now private, when we say private, they will not take requests from internet. They're not internet exposed. They're private. Your app servers, your database servers, you don't want to expose to public. Nobody wants to talk to it except these web servers. Ideally, if you guys know about this 3-tier architecture, the typical one, your web server will talk to the application servers, and your application server is the one that talks to database. Even web server can't talk to the database. That's how you want a typical 3-tier architecture, right? Now, So far, I named this subnet as public, I named this subnet as private, but by naming this subnet as public, will it become magically public? How will it be able to take the request from internet? At this point, it can't. There is no route to internet actually. If this web server wants to go out and then let's say sudo yum install httpd, it will not be able to connect to internet because there is no route to internet here. There is only one route, which is your local target, meaning it's your local route. Okay, it's only talking to everyone else within the VPC. It can talk to outside people. It can talk to outside VPC at this point, meaning even though you define this as public, there's nothing public about it at this point. These both are exactly same. So how can we make this public? So how do I make my public subnet really public? How can I do that? So this is there is something else called internet gateway. Okay, this one, you have to create an internet gateway. Internet gateway is responsible for taking the traffic from internet outside of the VPC, the real the internet, the entire globe internet, right? So internet gateway is responsible for acting as a gateway, okay, to send the network packets out to the internet, or when somebody is trying to reach to a guy here, this internet gateway is the one acting as a front gate and then take the request and then gives it to the router, and the router, by looking at the route table, it will define, okay, where do I go? Now, I got this internet gateway. I created an internet gateway, and you have to attach that internet gateway to your VPC. After you attach your internet gateway to your VPC, now you create a new route table, because the default route table, you look at this one here, default route table has only local route, meaning everyone can talk to everyone within the VPC. Only that. There is a route only to everyone within the VPC, but there is no route out to internet. So what you need to do is, you create a new route table. When you create a new route table, by default, this local, you can't change it because everyone should have a route within the VPC. But now what you're doing is, you created this internet gateway, right? Okay. Now you give that internet gateway ID and then say that my destination is o.o.o.o/o, meaning, do you know what this means? When you say o.o.o.o/o, means everyone, right? Anywhere. So everyone else except this local guys, everyone else, it has to go through internet gateway. You are providing a route, meaning if this guy is trying to go to google.com, it will go to internet gateway. And internet gateway is the one that's responsible sending the packet out to google.com. If you do not put an internet gateway to your VPC, you will not be able to connect to your internet. Does that make sense? When you create a custom VPC, by default, there is no internet. There is no internet in, there is no internet out. This web server will not be able to go out and do a sudo yum install or update. It can't do that. Similarly, if people want to come, if people want to reach out to this web server, they'll not be able to. So now I made this public subnet public. Now this is public, and this private subnet is really private, because if you look at this private subnet's route table, there is only one route. This guy does not have route to internet gateway. So that means app server will not be able to go out to internet, or anyone else can come in. No one can come in because there is no route. This guy will say that, I'm sorry, there is no route here to this one. Only local. But you are calling from somewhere else. You are calling from outside, right? So when this guy gives it to this one, the internet gateway is not there. Internet gateway is not attached to this one, so there's no route here. Make sense?
One question.
Absolutely. Go ahead.
Yeah. So far we created, exposed many S3 buckets and EC2 instance S3 web servers. So it means we are able to access that from outside. It means by default, gateway AWS is creating for us.
Fantastic question. So the point is, all along I've been creating these web servers, and I'm able to connect to internet. What the heck is happening there? Well, what's happening is you've been playing with not custom VPC, but they call it default VPC for your account. The default VPC, when they created it, they will create an internet gateway and attach to your default VPC. That is why you are able to connect to internet. But when you create a custom VPC, it's all you. It's all your rules. You define it. You have to create an internet gateway and then attach that internet gateway to VPC. Internet gateway is the one that orchestrates the packets out or packets in. Make sense, guys?
Good.
So this diagram, right? I will take out this. I want to make it little. You understand this availability zones and region, everything. Now let me draw this for a little bit of clarity. I took out that whole region and availability zone concepts. Now let's keep only the VPC part. So this is my VPC. Okay, my VPC is in this range 10.0.0.0/16. Okay, and I have an internet gateway created and attached to the VPC. And I have two subnets, public subnet and private subnet. My public subnet has route out to the internet. 0.0.0.0/0 is internet gateway ID, whatever that internet gateway ID is. Okay. And earlier I put the network ACL like this, right? But I've been saying network ACL is the police guard for your subnet. So let's redraw that. I'll put the network ACL here. Okay. So network ACL, I moved it to depict that it's a police guard for your public subnet, your subnet. It doesn't matter whether it's public or private. Okay. So now this is your public subnet 10.0.1.0/24. This is your private subnet 10.0.2.0/24. And your private subnet is private because this guy is attached to a route table, at the default route table, that has only one entry, which is local. Okay, meaning there is a route to your VPC. That's all. There is no other route. That is why it's private, guys. Now, from internet, when there is a packet coming in, and someone is trying to reach out to your web server here. Your web server is here. Somebody is trying to reach out. Okay, your router takes it. Your internet gateway takes it. Your internet gateway is acting as an orchestrator, right? It's taking the request and gives to the router, and the router will say that, okay, do you have a route to here? Oh yes. Looks like I can take from internet gateway. Looks like there is a from internet gateway there is a route to this one. Okay, sure. I'll give it to the subnet. Before give it to the subnet, we'll say that, hey, network ACL, whoever is a police guard here, can you see if it's can you apply the rules and then see if it's if it can be allowed, if this guy is allowed to talk to this one. Maybe I denied certain IP address. You can deny certain IP addresses in network ACL. Okay, if network ACL allows it, then it will go to the subnet, and then there is something else here, right? Right in front, before it gives it to the it gives the request or packet to your web server. Who will be here? There is another police guard here, right? Right in front of your instance. Who is that? Who is that guy?
Security group.
Your security group. Your security group. So there is another police guard here. There is a police guard here for the entire subnet. Here you can define the rules. Once you cross it, then you enter into your apartment complex, you can say that, or some subdivision. Now within the subdivision, you have multiple homes there. Now for each one of them, you have a security group. Or of course, you can reuse the security group across multiple. Now the security group is responsible to see if it's allowed to talk to web server or not. Network ACL at the subnet level. Your security group is at the instance level. There are some more differences between these two. We'll talk in depth later, but essentially that's all it is. And there is a security group also for your private subnet. So at this point, the public subnet guys, if this web server wants to talk to app server, will it be able to talk to it? Again, it goes to your, it goes out first of all, when this web server wants to talk to app server, what happens is, because we understand from public internet, the packet cannot come into private subnet because there is no route out or there is no route in. There is no route in the route table. Agree with that? Now, my public subnet guy, my web server wants to talk to app server, can it? What happens is, when you try to talk to it, first the packet goes into the security group, because the security group is the first level of police guard, first level of security here. Okay, first your rules will be applied there, and then if security group allows it, then it goes out to the subnet, and then subnet, there is another police guy here for the entire subnet. Packet comes out of the subnet, it goes through the network ACL rules. Okay, can I go out? Okay, then it will see. Let me see if you can talk to this one. If, let's say there are no rules here at the ACL level, then your router. Now your router will look at the route table and then say, do you have a route here? Yes, you have a route to your local. Okay, then I will let you talk to this one. No, I will let you talk to this one is a wrong sentence, I think. There is a route here, let me send it. Okay, and then again network ACL will come into picture and then say, maybe your network ACL allows out, but this network ACL may not allow in. Maybe there are some rules out there, but this network ACL will see that, okay, yeah, looks like you can talk to it. Okay, let me allow it. And then before this guy is talked to, then your security group is there, the final security guard there, and then say that, are you sure you can talk to it? Okay, then if this rule allows, then it will be able to talk to it. Understand, guys? Pretty easy, right? Not really easy, but it's not majorly complex. Also, I think we can definitely we can work it out. Not a big deal. Okay, my private subnet needs internet. Yeah, I understand. We'll get to this one later, maybe in a separate part. At this point, my private subnet does not have internet. Does not have internet meaning it's both sides. Internet guys can't talk to my private subnet because there is no route out. But the sad part is my app server cannot go out too. There is no internet out also, meaning if I want to apply some security patches to my app server, I can do that. If I want to do a sudo yum update, I can't do that. That is a sad part. At least I need that, right? I mean, I don't want anyone to come inside, but I want to be able to go out to internet so that I'll get some security updates. I'll get my new software and all. Right? That problem still exists. We need to solve it, but we'll solve it in the second part. Make sense, guys?
Venkat, I have one
Yes.
small question.
Mm-hmm.
So we are creating these CIDR ranges, right? So let's say I created this custom VPC and I gave the range to be 10.0.0.6/16. And can other person also create with the same CIDR range?
Yes.
And can use the same IP ranges, basically.
Mm-hmm.
10.
Absolutely. Actually, it's a great question. Thank you for asking that. So Nischala, so she has AWS account, so she's able to create the 10.0.0.0/16, and then let's say another guy here, right? So we all want to create the same 10.0.0.0, and we are all multi-tenant, and we are all within AWS. It's already taken. How can I create one? That's why it's a virtual. They will mask all of this one, Nishila. The AWS people will mask all of that, and then they will create this virtual. So even though this is, that's why they call it virtual private cloud. It's virtual, and everybody can create the same 10.0.0.0. Because I've created it, it's not taken for you. You can have the same. Absolutely.
Okay, thank
you. Yep. Any other questions? Very good questions. If not, let's go ahead and log in, and let's play with it. So let me do this. Okay. So now let's go ahead and create whatever we have been discussing the last 1 hour or so. So let's go ahead and create a VPC with this CIDR range. How do we do that? Let's tackle one step at a time. Let's go ahead and log in. So now go to EC2. We have any running instances? Nope. So now let's go to services section, and then under networking is VPC comes under networking section. So go to networking and content delivery, go to VPC. So there is one VPCs, one VPCs here, which is the default VPC. Okay, this is the default VPC. If you really look at it, this is the default VPC, and you can look at the internet gateways. See this one? The reason this is the default VPC. So, right, and this is the default VPC, and the IP range that he picked default is 172.31.0.0.0/16. /16 is the maximum that they allow. You cannot use a lesser number than /16. So within your VPC, the maximum is a maximum number of IPs that you can have is 65,000. About 65,000, right? So we'll name this guy as a default VPC, so that it's we will know what is default VPC and what is custom VPC. So this is a default VPC available state, and this is the IP range that he picked up, and this is the main route table. We can go to route table, and you can take a look at the routes. See this one? You have a same VPC CIDR as target as local, meaning you will have access, local access to all the people within that VPC. This one you can't change it. You can't lower it down, because you need to have route to every single resource within that VPC. But see this one here, O.O.O.O/O is your internet gateway. This is your internet gateway. So this is the reason, this line is the reason why you're able to have internet access. You can edit the rules, and you can delete it. You can remove it, and you can check whether you get the internet access. You should not. So this is your internet gateway, and this internet gateway is attached to the VPC, which is your default VPC. Make sense? So I'll call this guy as default internet gateway, default IGW, I'll call it, okay? So that because we will be creating all custom now. Let's go back to VPC now. Click on create VPC. So we are creating a brand new custom VPC. I'll call this as a custom VPC. And then IPv4 CIDR block. So what's our CIDR range? We said 10.0.0/16. This is the IP range that we wanted to take it. 10.0.0/16. Yep. And IPv6 CIDR block. Do you want IPv6? No IPv6 CIDR block, but you can even use Amazon provided IPv6 CIDR block. Or if you have anything owned by you, you can define the pool and put it here. I will say, let's not worry about IPv6. Okay, let's worry about only IPv6, IPv4. So tenancy, obviously it's a default tenancy. This meaning it's multi-tenant. I don't want dedicated one. So yep, this is good. A VPC is an isolated portion of AWS cloud populated by AWS objects such as your EC2 instances. You must specify an IPv4 address range for your VPC. Specify the IPv4 address range as CIDR block, your /16, /24, /22. Okay. Oh, so the default, actually what he gave is 10.0.0.0/16. You cannot specify an IPv4 CIDR block larger than /16. There you go, he mentioned it clearly. So if I try doing /12, so it will say that block sizes must be between /16 net mask and /28 net mask. So it must be /16. Let's go ahead and create it. We got new VPC. We called it custom VPC. There is already a default VPC, and we created a custom VPC with this CIDR range. So let's go back and make sure you know what we did. What we did so far is we created this VPC with the 10.0.0.0/16. And as I said, there is an implicit router. In addition to that, there are two things that it creates when you create a VPC. It creates a default route table and it creates a default NACL. Let's go ahead and see if they got created. Go to route tables, go to route tables. Okay. So see this one, there is a default route table for your default VPC. I will call this guy as default route table for your default VPC. Okay, and this is not our VPC. This is so now when we just created a custom VPC, it created the route table. Okay, and this is called, we can call it default route table for custom VPC. I'm just naming it so that we will be able to read them better. That's all I'm trying to do here, guys. So this default route table has been created. So let's take a look at the routes. There is only one route here, 10.0.0.0/16, and target is local, meaning you will have your local target. Okay, it's not internet gateway, it's not any instance, meaning you will have local access to all the people. Okay, this is what has been created. What will it do? Well, it will give you a route to all the other resources within a VPC. Does it make sense? Even if they are in different subnet, you will have a route there. Whether you will have access to it or not is different. That depends on a lot of factors like network ACL and security groups and all. So we observed the default route table, and let's go observe the default NACL, whether network access control list has been created. So let's go to security, network ACLs, and take a look at this one. This is a default VPC, and this is a default NACL. So this is default network ACL for your default VPC, right? This is not ours. This is not ours. This was created default for the default VPC, but this is our custom VPC one. So this is our default NACL for our custom VPC. So this is automatically, when I created a custom VPC, this guy got created automatically is all I'm saying. It is currently Let's take a look at all the rules here. Network ACL rules, inbound rules. See this one. So network ACL, we will get to this in depth little later, either today or tomorrow. So essentially, it's a NACL, network ACL, is nothing but the numbered rules. You can have a rules from 1 till any number. Like these guys are executed in order. Like in this case, it's rule number 100. Rule number 100 says all traffic, all protocols, all port ranges allow. So meaning everything allowed. This NACL will allow everything. So if you attach this one to a subnet now, there are no rules at the subnet level, meaning it allows everybody to inbound traffic, meaning from public internet or from outside traffic coming in, and outbound rules, meaning when an instance is within a subnet, it's trying to go out either to internet or somewhere else. All these outbound rules are applicable. So this is rule number 100, says that all of them allow it, all traffic allow it. If you want to deny to somebody, you have to define a rule less than 100. So you can define your rules like 100, 110, 120, or even 101, 102. It's a numbered rules. It goes from it goes from in an ascending order. Okay, and if rule number 50 allows it, a packet allows it, it doesn't execute the rule number 51 because it says allow. If rule number 50 says that it denies it. It doesn't execute the next rule number. So we will talk in depth on that, but essentially that's what it is. So all I'm saying is a default NACL is created with that says everything is allowed. Okay, so let's go back. We created a VPC. Implicit router has been created. We don't look at that because it's an implicit router. So this router will read the routes from the route table, and we looked at the default route table, and it allows traffic to internal within the VPC. And we also observed that there is a NACL that allows everything. Now, well, I just copy pasted here, I depicted here. So we observed it. Now, what's the next step, guys? Let's create a public subnet. Let's create a new subnet here. We did not. So let's go to subnet. So far you have all the, how many subnets you have it? Oh, I'm in Northern Virginia. That's why. So Northern Virginia has 6 availability zones. So when by default with your account, okay, a VPC gets created, an internet gateway gets created and attached to the VPC. And also it will create a subnet, one subnet for each availability zone. Okay. So if you had created in Ohio, then you would have seen 3 subnets. Okay. So these are all the default subnets. These are all the default subnet. I don't want to name it, but let's go ahead and create a new subnet. I will call this guy as public subnet. Okay. This is where all of my web servers sit. Public subnet. Now I'm saying what VPC. Where do you want to create this subnet? Custom VPC or default VPC? Well, custom VPC. And then where do you want to put this guy? What availability zone do you want to put it in? Well, there are 6 availability zones. So let's start with 1A. I selected 1A. And this is your VPC siders. So 10.0.0.0/16. This is your big set, your superset. Now, within that, what is this subnet's cider block? 10.0.1.0/24. When we say /1.0/24, you will get 256. Out of 256 IP addresses, 5 are taken by Amazon, AWS, and then you will be able to create 251 resources. 10.0.1.0. 1.0 is for public subnet, 2.0 is for private subnet. That's what we're trying to do it here. So what are we trying to do? We are trying to create this public subnet. Let's go ahead and create it. Close it. Public subnet has been created. Okay. When a subnet is created, by default, the reason, earlier we looked at your route tables, right? The reason they are called a default route table is because as soon as a subnet is created within that VPC, it will attach, the default route table gets attached, the default NACL gets attached automatically. You look at that, your subnet. If you look at the route table, see this one? Your default route table for custom VPC has automatically been attached implicitly. And go to network ACL. Your network ACL also, see this one? Default NACL for your custom VPC will automatically be attached, meaning all the allow, inbound full traffic allow, outbound full traffic allow, this network ACL is attached automatically, implicitly. That's why they call it default. Okay. So at this point, we created a public subnet. The same default route table is attached. Same default NACL is attached. Now let's go ahead and create one more private subnet, and same thing will happen. Same default route table get attached. Are you guys following it? Let's go create one more subnet, and I will call this guy as private subnet, custom VPC. And now this guy I'm going to create in a different availability zone. Now I'm trying to do this here. Absolutely. Can I create in the same availability zone? Absolutely, you can create it, but I'm putting it in a different availability zone. This private, I want this private guy in a different availability zone. I'm doing it. All my app servers in a different availability zone. In this example. So 1B, I'm putting it, and this is my CIDR for VPC level. So what is your subnets? 10.0.2.0/24. 10.0.2.0/24. Yep. 1.0 IP addresses. So are all web servers, and these are all the app servers, application servers. Let's go check. At this point, your public subnet, route table is attached. Same route table, the default route table, the default NACL is attached. If you look at the private subnet, same default route table has been attached. Default route table will give you route to every resource within the VPC, and your default NACL allows everything in inbound, and outbound also allows everything. So we created two subnets, and they both are attached to the same route table and same network ACL. So even though we named them public and private, okay, there is no difference between them at this point. Both of them are private because there is no, now if I try creating EC2 instance in a public subnet, I can't even connect to it. Does it make sense? Because there is no route in, there is no route out. Does it make sense? So, the next step is this one anyway. Let's provision EC2 instances in those subnets. So let's provision 2 EC2 instances in public subnet, two web servers, and let's provision 2 app servers in that private subnet. Can we do that? Let's do that. So let's go and go to EC2. I don't have any running instances in Northern Virginia, so launch instance, Amazon Linux 2 AMI, general purpose T2 micro. Now we will go a little slowly here. All along we've been saying, yeah, click next. Now let's take a look at this network here. So by default, it's saying default VPC here. See, all along you click the next without even looking at all of this one, but the default VPC has been used. But now let's do it in custom VPC. What are we doing? This is a web server 1, custom VPC. And do you want to do it in a public subnet or private subnet? I want to do it in public subnet. I'm creating this guy here. Public subnet and auto assign public IP. Sure. Yes, please. Auto assign public IP, use subnet setting, disable. At this point, your public subnet, even though you named public subnet, and also look at this one, 251 IP addresses available. If you, after you create this web server, next time when you try creating the next one, it will say the 250 IP addresses available, because within the subnet, it's a /24. The maximum is 255, 256. Out of 256, 5 are taken by AWS. So that's why 251 are available. Make sense, guys? Now, see here, auto assign public IP. So there is no public IP to this one. The reason is it's a default setting. The default setting for the public IP, I'll put it as enable. The reason is the public subnet at this point is not really public because there is no internet gateway attached to it yet. There's no route out to the internet gateway. Make sense, guys? Okay. Enable. I said, since this is a public, this is going to be a public web server, I said auto assign public IP as enable. Okay. Placement group, no capacity reservation, IAM role, no shutdown behavior. All of this, we can leave it as is. I don't need to do anything. Let's go ahead and add storage, add tags. I will say that this is a web server 1. Okay, I will call this web server 1, web server 2, app server 1, app server 2. Okay. Security group. Yeah, do you want to create a security group or create a new security group? I'll call this as a WebDMZ security group. Okay. And port 22, I want to be open to everyone, sure. And to HTTP.
It is right above the, you were there actually.
Or I can even call custom port range. Oh, sorry. Did I say custom port range? HTTP, I'm sorry. Port 80. Thank you. Review and launch. Let's go and review. And I want to create a new key pair. I'll call this custom VPC key pair, and I want to download it in case I need it. Launch instance. Okay, I opened port 22 to everyone. I've opened port, as I say, port 22 should not be open to everyone. And I also say, I also said that port 80 should be open to everyone because these are going to be web servers. But at this point, you can't go in. You can't even connect to this. This web server is created, but you can't even connect. There is no route. There's no internet gateway. There's nothing there. So there's no way you can connect to it. Make sense? So we can even prove that.
Got one question, like these key pairs we are creating in Northern Virginia region. So you can use that key pair for any instance.
They're region specific.
Region specific.
Yep. So I will not be able to connect to this machine right now. You know why? Because there is no route out. We created this one. There's no route in, there is no route out, there's nothing. So you try 1 year and nothing will happen. So what did we do so far? We created one web server. Let's go ahead and create one second web server also. Just actually one may be okay. Let's create one app server in the private subnet. Okay. So let's create a launch instance. And my network is going to be custom VPC, and my subnet is going to be in a private subnet. And see here, 251 IP addresses. If I select public subnet, it says 250 IP addresses because we have taken one IP address already, right? Because web server 1 took it. So I'm doing it in a private subnet. And auto assign public IP, use subnet setting, disable. I do not want public IP for my private for my app server because it's not going to be public anyway. Are you guys with me? All of this, we can leave it. We can leave it add storage, security, name. This is, I'll call it app server 1.
Did you create this in different zone?
Different subnet. Yep, I created here. Oh, different zone, different availability zone. I selected subnet because at the time of creation of the subnet, I said this subnet must be created in 1B. This public subnet was created in 1A. This private subnet was created in 1B.
Okay, to carry.
Am I making sense or no?
Got it.
Yes, I wanted to ask that question, Venkat, that can we have VPC over different regions?
VPC is a region specific.
VPC again, region specific. Okay.
Yep, VPC is a region specific, and subnet is availability zone specific. So when I created a subnet, I said that this private subnet must be in 1B and this public subnet must be in 1A. And now at the time of creating my app server, I selected that I want to create this app server in this subnet, in this private subnet, and private subnet is already there in 1B availability zone. No confusion there, right? Create a new security group. I will say that this is a app server security group. App servers security group. Port 22 to be open. I want port 22 to be open only to who? Actually, I want port 22 to be open. I do not want to connect from outside, okay? Because there won't be any internet also at this point. I won't be able to connect. In fact, I can only be able to connect to this from my web server. Okay, that is what. So ideally, I want to open my port 22 only to custom. We'll just say security group dash. So what I'm trying to do is I'm saying port 22 is to be open to web server security group, meaning these guys will be able to connect to me. So there is no way from internet, from your house, you can directly connect to this private subnet. You have to log into the public subnet, and from public subnet, you have to connect to it, is what I'm saying. Does it make sense? So this is port 22. And let's say there is a Tomcat instance running there. I'm making it up, but let's say there is a port 80. No, HTTP, no. There's a custom port. Custom VPC, private subnet. Create new security group, app server SG. This is a custom protocol. Custom TCP rule. My TCP port 8080. So I want port 8080 to be open to my WebDMZ security group. Make sense? Does this make sense, guys? I have a Tomcat. There is a, like Tomcat is an application server. Okay, it's like an Apache, but it does more than that. It's for dynamic requests. If you have a Java application, if you want to Java web-based container essentially. So if you have a Java-based application, web application, you can drop that. You can deploy that. So that typically runs on port 8080. So I'm doing it. Go ahead and launch custom VPC guy. View instances. Make sense? Okay. Now we did this so far. I think we created one each. And now how to make public subnet really public. At this point, these both are exactly same. You just named them public and private, but they are exactly same. Okay. So how do I make my public subnet really public? At this point, I can't connect to web server 1. I can't connect to app server 1. I can't do anything anyway. So even if you try to connect to it, you know you can't connect. I don't need to demonstrate that. Because there is not even a public IP actually. So that is why, there's no question there. So what do we do now? How do I make my public subnet really public? My internet gateway. So go to your VPC section. Go to your VPC section. Here, go to internet gateways. So let's leave this default, internet gateway as is, because I wanted to show you how to create a new internet gateway. Create a new internet gateway. And I'll call this my custom internet gateway. It's not the default, my custom internet gateway. My internet gateway got created, but it's detached. Currently, it is not attached to anything. And I want to attach my internet gateway to VPC. That's it. So what did I do just now? I created an internet gateway and attached to VPC. Now my VPC will have internet. Okay. But just by attaching an internet gateway, you don't magically be able to connect to these public subnets, or this public subnet will magically get an internet. No, you need to update your route table. Am I making sense? You need to, in the route table is the one that is read by your router, right? So you need to update your route table. In fact, at this point, there is only one route table, the default route table. That default route table is attached to both public and private subnet. That is why both of them don't have internet. So I will leave the default route table to my private. I'll create a custom route table, new route table. I'll call that as a public route table. And there I will put my internet gateway. Does it make sense?
One gateway, one is must, or we can connect the same gateway to multiple VPCs.
Can you say that again?
So one gateway can connect to multiple VPCs?
You cannot connect. Yeah, it's one-to-one. It's one-to-one. So now let's go ahead and create a route table.
So Venkat, have a question.
Yep.
So the existing public and private subnets are connected to the default route table, right? And the default route table has the default gateway which is open to public. Why the internet is not?
No, the default route table doesn't have it. See this one? Default route table has only
the target IGW and it is.
Sorry, this is for this is not our VPC. This is not our VPC. This is a default VPC, right? This is not our VPC. This is our VPC, right?
Okay.
Understand? So when you create a AWS free account, I told you that it will create a default VPC. It does few things. It will create a default VPC. It will create an internet gateway and attach that internet gateway to the default VPC also. That is why somebody asked that question, right? How come I've been able to, connect to the internet? It's because your internet gateway has already been created and attached to your default VPC, and you have been using the default VPC. And in the default VPC's default route table has this one. That is why you're able to do it. But this is not our route table. Does it make sense?
Yeah, got it.
So this is our route table. This is our route table. This is look at the picture here. So far we are here, and this is not there. Only this route table, and go to the subnet association. Both the subnets are associated to this one. There is no exclusive association, but read this one. The following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So this is the main route table. See this one? This is a main route table. I'll call this as a main route table or default route table. So this guy has only one route. That is why there is no difference between private or public. Both of them are attached to the same. So what we will do is, now let's go ahead and create a new route table. I can mess with the existing route table, by the way. But the problem is, if I mess with the existing route table, both of them will get internet connection. I don't want my private guy to get the internet connection. Does that make sense?
Yeah, yeah, Venkat. Yeah, now it makes sense. Yeah, thank you.
So let's go ahead and create a, thank you. Create a new route table. We will call this one as a public route table. I'll call this as a public route table. Public RT to my custom VPC. My public route table for my custom VPC. Being explicit. Very good. So now let's go to public route table to my custom VPC. Go there, and by default you will have this one, meaning you will have route to. Click on edit routes now. Okay, this one you will have it. This one you can't do anything about it, meaning you can't change this one. The reason being is because you want you need a route to every single resource within a VPC. Within VPC, they're all within your subdivision. There's no, you have to have a route there. Now let's add a new route. I'm going to say that o.o.o/o, meaning anywhere, everyone go to your internet gateway. Internet gateway. I just enter here IGW or something. No, that's an instance. Now let's say search for internet gateway, and then it will show me that. See, it is only showing me my custom internet gateway. Okay, because that is what is attached to your VPC. And did you understand why I said one-to-one? Is because of this. Okay, so now what did I do, guys? I added this an additional line here, and I created a brand new custom route table. And I added this one. Now my custom route table has been created at this point. Internet gateway has been created, my custom route table, but this association is not there. My public subnet is still associated with the default route table. Are you guys with me? My public subnet, go to public subnet, your public subnet, okay, you go to route table, it is still associated with the default. Even though we created a new route table, we did not change the association. Let's go change the association. So we will change it to public route table custom VPC. So this guy has both of them, internet gateway now. Now your public subnet is attached to public route table, and your private subnet is attached to default route table. See, the default route table does not have internet gateway, but your public subnet has both local and your internet gateway. There are two entries there. Now it's truly public. Now your subnet is public. Your public subnet is public, private subnet is private. Now internet gateway has been created, attached to VPC, and a brand new route table has been created. I called this as a public route table, and I have attached to the internet gateway. And even I did the association this one to this one also. And my private subnet is still associated with the default route table, and I want that to be that way. Because I do not want my private subnet to have internet, or I do not want my private subnet to be exposed to the internet. Both inbound and outbound.
When our application is spanned across different regions, so in that case, we need to maintain different VPCs and everything, all subnet, private subnet. We need to kind of a duplicate copy in other region, right?
Can you repeat the question? The first part I missed it now.
When our application is spanned different regions, so it's not in Virginia and London region, our application is.
That's correct.
Places.
That's correct.
In that case, our VPC need to be in two places, like maybe the same rules apply here and there.
Yep. I mean, it's a completely different now, because it cannot span your region. Simple. So you'll have to recreate it.
Make a copy another kind of with same rules.
You can do that. Yeah, you can do that. I mean, you can have exact same thing, but essentially whether you copy it or doesn't have to copy it, But my point is, since it's a region specific, you will have your own rules governing them. You can have exact same replica, definitely, you can have it, but you don't need to, is my point. Make sense?
Maybe there will be a better way instead of copying everything.
No, actually no. And I don't want to copy also for all practical purposes, right? It's a completely different region. And it's a completely different region, and it's a brand new VPC, and the rules are different. Everything is different. You want to rethink about it.
My question is the application. So everything is same, but underlying applications are same. It's a kind of a replica copy.
If your application, if you are maintaining an active standby mode, yeah, you'll create a brand new VPC. Yes. You'll create a brand new VPC and brand new roles. And you may be asking, how will I be able to create this exact same thing? So remember in the beginning, I said advantages of cloud, you can do an infrastructure as a code. So you can code this complete infrastructure. There are some options out there. One of them is called cloud formation template, AWS cloud formation template, where you can write script. You can create script. You can script whatever we just did, right? You can script it and pretty much execute the script. From your command line, from your CLI also, you can do it pretty much. Connect to one region, run the script, connect to another region, run the script. You see what I'm saying? So that you will have the exact replica, if that's what you like.
Yeah, we have to do in real life.
Mm-hmm. Okay, so how do we make this public subnet really public? Yes, we did it. So, and I'll leave this, this picture here, and this is really public. Now let's go try and then see if we are able to connect to your web server. Let's see if we can go connect to your web server. You're able to connect to your web server because your VPC has internet now, internet gateway attached to your VPC, and then you gave a route in your route table to your internet gateway, and you associated that route table to your subnet, and this web server happens to be in that subnet. Understand the relation, guys? And I will tell you, before you go into the exam, you have to be able to picture this completely in your brain. It's like when a traffic goes from a network packet goes from public internet into your web servers, how it will go. How will your network packet travel from internet into your web server? Or when web server is trying to go out, how will the network packet go out? You have to be able to picture that in your brain. You have to be that thorough with VPC concepts before going into the exam. Okay? So we did that. So let me step back here. We really made it public. Very good. Now, is there a way you can connect to this app server? Absolutely not, because there is no route out. No route. So now, how will I be able to connect to this app server? How will I be able to connect to this app server? So what we will do is, let's log into this web server. Let me show the picture here. Let me log into this web server here. Let me log into this web server. From web server, it should be able to connect to this app server, right? I will try doing that. So let's log into the web server. And then what is the private IP of my app server, right? 10.0. 2.103. See this one? Hey, all along, you have no control over this one, right? I mean, in a way you do. I mean, because your default VPC has 172 dot something. So yeah, based on the default VPC, your subnet has been created. Now, this is your private IP, 10.0.2.103. Copy it. And then now, let's see if I can ping it. I can ping it because pinging is a different port. You know, it's an ICMP port that has to be open. It's not open. Only port 22 is open. Let's say SSH EC2-user at this private. Are you sure you want to connect? Hey, so I'm able to, nope. It said that it tried connecting it. Are you sure you want to connect to it? And then it said that permanently added 10.0.2. This is all good. Permission denied. Why? Because I did not provide the key. Because I did not provide the key, I was not able to connect to it, but port 22 is open. It clearly told you this one. See this one? The authenticity of this host can be established. It's saying key fingerprint. Are you sure you want to connect to it? So it actually attempted to connect to that machine. Okay. It's just, it failed at the public key because I did not provide the private key. So what I'm trying to do is I'm logged into this web server. From web server, I want to log into app server. That's what I'm trying to do. Because that app server is not open to the public. Make sense, guys? Now, what do I do? How do I log in now? I was not able to log in. This 10.0.1.156 is my web server IP. 10.0.1.156 is my web server IP. My app server is 10.0.2.103 because it's in a separate subnet. That is why the IP address is different. 10.0.2.0/16. Remember that? Guys, are you able to connect the dots? 10.0. This is our 1B subnet. 10.0.2.0/24 is what we gave. The first IP is 10.0.2.1 until the last IP is 10.0.2.254. Is this one of the ranges? 10.0.2.103. Yes, this fits perfectly between these two. Are you with me? So I want to connect to this one. So what I want to do now is I need my private key. So I downloaded my private key, right? So I will go here. I'll download my private key. I already downloaded my private key. This is my private key. So I'll copy this private key and put it in my web server. This is not the best way to do it, guys. Copying the private key into web server is dangerous because your web server is in DMZ, demilitarized zone. And if at all your web server is attacked, and if somebody got handle onto your web server, they will have access to your private key sitting out there, and they will be able to log into your private also. So private servers also, or your app servers also. So this is not a recommended approach. I'll talk about it. What's the better way? There is something called Bastion host. We'll talk about that. So probably tomorrow. So let's not worry about it. So for now, let's do this. This is where I'm creating now. I'll say my private key. Private key dot, it's a PM form. This is what format? This is PM file, yeah. Dot PM. And press I there. I used VI and copy paste it. Right, quit. But the only problem is now do an ls minus lrt. So it has more privileges. So we have to reduce the privileges to a private key. Otherwise it will not work. chmod 400 to private key. Now do an ls minus lrt. I reduce the privileges. So only owner can read it. No one else can read it. Only then it will work. See this one, permission I gave 0. So that's what you will be able to see it here. So now I should be able to connect SSH EC2-user at my private instance app server IP is this one here. Minus I private key.pm. I'm logged in. I'm in my 10.0.2.103. This is my if config, like how you can use IP config, right? This is a Linux command or any of the Unix commands. So this is what tells me what IP address is. My IP address is 10.0.2.103, and that matches with my 10.0.2.103. I'm logged into my private machine now, my app server now. How did I log into my app server? I was logged into web server first, and then from web server, I was logged into app server. How? By copying my private key file, PEM file there. Is this the best way to do it? No, it is not. Because I copied my private key there. So I don't want to copy private key into a server in WebDMZ. It's a bad idea. Okay, but I wanted to know this is one of the ways. We'll find out. There's another way. That's using the Bastion host. So we'll talk about that. I think we did that. So we redo this for clarity. How about security groups? I think we already put the security groups there, right? We use the security groups at the instance level. We created a security group called web server security group, and we allowed port 80 to internet and port 22 to internet, port 22 to everyone, port 80 to everyone. So that is why we are able to log in from public internet into this one using port 22, your SSH port. And then if you really install HTTP server here and open up, you'll be able to, from internet, you'll be able to connect to this one also. From internet, you'll be able to send a HTTP request. You want me to show you that? I mean, I think you guys did it several times, right? I'll do an exit here and I'll come back to my 10.0.1.156. This is my web server now. Okay, this is my web server. This is where my PEM file is and all. So you can do, you'll be able to connect to internet. There's no doubt about it. Sudo yum install httpd. Oh, we can prove that. We can prove that. So I'm changing gears a bit. I'm in my web server. I will try, I'm trying to connect to internet and then see what happens. Sudo yum install httpd. There you go. I'm able to connect. I'm able to connect and it's asking me, are you sure you want to do it? Yes. I'm able to connect and I installed httpd. Okay. Sudo service httpd start. Let's go ahead and kick off your Apache. Let me do I'll do a VI. You can do a nano if you're not comfortable with it. I'll say this is my web server 1 created in my custom VPC. Yeah. Let's go check. This is my app server 1. This is my web server 1. This is my public IP. This is your public IP, guys. This is your private IP. This is your private IP 10.0.1.0. Remember, we gave CIDR range, but that's not how you will be able to access it from public internet. Nope, you will get your public IP here. Take the public IP and go. This is my web server 1 created in my custom VPC, the text that I just put here. Make sense, guys? So we were able to prove that this web server was accessible from outside. Okay. And also this web server has internet going out because we were able to go out and get the Apache server from internet and installed it. So two-way internet connection is there thanks to our internet gateway. An internet gateway is attached to our VPC, and that was referenced in the route table, and then route table was associated to a subnet, and that subnet is what we have used while creating our web server, meaning our web server happens to be in that subnet. That subnet happens to be associated with the default, with the public route table, And that public route table has a route to internet gateway. And because of an internet gateway happens to be associated with VPC, that is why the two-way internet is possible. Any questions? It's possible, right? Now, this is what I want to prove. Since this internet gateway is not attached to this private subnet through the route table, because there is only one route entry there, which is to a local route, okay? The internet gateway is not referenced here. What does it mean? Meaning your private subnet does not have internet. So you are not able to connect to it directly. Makes sense, because port 22 was not open anyway too. But what we were able to do is, we were able to log into public subnet. So log into this web server, and then from web server, we were able to log into this app server. Absolutely, we were able to do it. But now what I wanted to prove is, after I log into this app server, I will attempt to go out to the internet and try downloading my web server. I will not be able to do it. I will not have internet. Not only from coming in, guys, I will not have internet to even go out and get something, because there's no route there. There's no route here, guys. It's only, you can only go talk to people within that. If you want, you can connect to this guy here. If you have the private key, your private key, if you can, yeah, you can connect to one of these guys. That's possible, but you can't go to internet because there is no route out there. Let's prove it. So I'm in my web server now. This is my home directory, home EC2 user. So I'll say, I'll use my command, this guy, right? 11. So you can do an exclamation mark and number 11, and you know, you can execute a command like that too. In it's a fancy way. Rather than copy pasting, I did that. Okay. So anyways, now where am I now? Where am I now? ifconfig. I'm in 10.2.2.103. This is my app server, guys. This is my app server. Now I try doing sudo yum install httpd. Stay there forever. You will not be able to connect because there is no route out. Also, internet gateway is not attached, or something else. Tomorrow we will find out what that something else is. You know, we understand this is an app server. We understand this is a database server. We understand this has to be private, and we understand this must not be in WebDMZ. I understand all of that, but it needs to be able to go out and get the operating system level patches updated, right? It needs to be able to go out and get some software, right? It's unfair, right? How can I connect to it? Well, I will answer that question tomorrow, but for now, it cannot.
Okay.
Yes.
Can you log into that application server and connect to web server?
Oh, can you? I'm connected to this one now. So,
Connected and use the private key to go to application server.
right. Okay. Okay. Yep. SSH EC2-user at it's web server 1. This is my private IP. It's permission denied because it is I don't have key, right? So what we'll do is vi private key .pm file. Okay. Chmod. Now -i private key. You're back in 10.2.1.156. See that? You are in web server now. And you can check your ps-ef grep httpd. Yep. This is so essentially what you did is you're logged into the web server from public internet. From here to you're logged into web server, and from here to log in back to the web server. There's no reason to do that, but it just what it proves is these guys, there is a route to everyone within the VPC. That's the point it proves. Okay. And of course, if I block at the security group level port 22, then I'll not be able to open. Yeah, I'll not be able to log in. Even if I block at the security group level, if I block that port 22, take out that port 22 rule, right? Then you'll not be able to connect. You know that. Make sense? Does it make sense? Now I'm back to private. Once I exit, now I'm back to public. That's it. So now the question, the interesting question is that my private subnet needs internet. Guys, I don't have an internet. I understand my private guy is a private and it should not take traffic from outside. I understand all of that. But not having internet to go out, I want one-way internet, guys. I need to be able to go out and get some operating system level patches. Come on, provide me a way. There is a way. There are a couple of ways. One of them is called NAT instance, network address translation. We'll talk about that tomorrow. I think that's too much for one day, mainly for VPC.
So can we create a HTTP for only specific to that private subnet and access the internet, not others?
I don't think I get the question. Can you repeat that?
No, like in the private subnet, we have a security group, right? So there is no HTTP basically. There is only SSH is available. Create a HTTP specific to that private site subnet IP address so that it only access internet. No, others cannot access internet. Can we do that?
So what you are saying is you update your security group rules, right?
Yeah.
Update your security group rules and allow port 80 to everyone.
No, not everyone. Only to specific that IP, that private subnet IP.
Not a problem. To that IP meaning who?
Whatever the application server IP.
So this application server, what is the objective though? Let's talk about let's go from what we are trying to do there. What problem are we trying to solve?
To get the updates from internet. So we are allowing only
to get the updates from internet. Okay. So your security group, sure. Security group actually it's a one directional. It's an inbound only, right? Inbound traffic only will be blocked because outbound is all. Security group is something called stateful, meaning you'll only specify the inbound rules. Your outbound is all allowed anyway. Okay. So security group is not the problem. The problem is when you try going to sudo yum install something, okay, it is trying to go to a website outside of this VPC. Okay. And there is no route out from this subnet. This guy is saying that I'm sorry, you don't have a route out to go out of this VPC. You can only talk to, I only have, since you are coming from this subnet is attached to this route table. I'm sorry guys, I have this, these are the rules that specified. You can only talk to other guys within the VPC. You cannot talk to anyone else. Understand?
Yeah, I got it. So in security group is a limitation, but in default route table, as of now, it's only 10.0.16. So it's communicating for local.
Mm-hmm.
So if we enter only the IP address, not to 0000 specific IP address, can it go outside? No, right? I think only inside. Yeah.
Oh, are you saying that? One second. So what you are saying is for this particular destination only allow it?
Yeah, so something like that.
Is that what you are saying?
Yeah.
Yeah. But again, you are attaching an internet gateway, right?
Yeah.
Then it's a two-way, right? I don't want that two-way traffic. I do not want this to be exposed at all, period. There is another way. If you want your private subnet to have internet, you do not want internet gateway. Internet gateway is a two-way bounded traffic, okay? So you don't want to use internet gateway. Rather, you want to use something called network address translation, NAT gateway. There is something else called NAT gateway or NAT instance. That's what you will create a NAT instance and NAT gateway in your public subnet, okay? And that one, that NAT gateway and NAT instance, you put it in a public subnet and you reference that in your private route table. That's what you do. That's what you get it. You'll talk about that tomorrow and we'll do it. Okay. This is how the diagram looks like. You create a NAT gateway and you reference that NAT gateway here. That's how you'll get the internet. We'll do that tomorrow. Okay, and there is some differences between NAT instance and NAT gateway. We'll talk about all of that tomorrow. So that's it, guys. Was it fun? It's a lot of fun, right? And especially we did it, this diagram, this PowerPoint helped me because we were going step by step, right? In a very logical, methodical fashion. So I like it. Now, the important point is, by the time we meet tomorrow morning at 8, you should have created this, at least 2 to 3 times, all of this, and be very comfortable with it. So that's the goal. So let me stop recording here, and then I'll give you the homework.